Hello and welcome to my channel. I am Mensah Augustine. Please, if you are new here, kindly subscribe to my channel, and if you have been watching my videos and if you not yet subscribed, please kindly subscribe for us to grow the mathematics community. In this lesson, we'll be talking about limits at infinity involving radicals, mostly square roots. So join me as we go through the lesson. Now, I've been saying that whenever you see my videos, watch for at least 10 to 15 minutes or watch the whole video, and you see that more secrets will be revealed as you have been enjoying before. Now, for the sake of Rosina from University of Ghana, Legon, I'll first start with these two questions, because she sent me this question to solve for her, and I told her that I'll be uploading videos on limits involving radicals, so she should wait for the video. So Rosina, this video is for you. We are going to look at the limits as x approaches positive infinity. Square root of x squared plus 4x divided by 4x plus 1 versus the limit as x approaches negative infinity. Square root of x squared plus 4x divided by 4x plus 1. Yeah, Rosina, you sent me this question, but I also do this and attack it to make you understand it more. Okay, if you find my videos very helpful, just subscribe to my channel, share, comment, and then like. And before we go through this, let's look at something here. If you remember basic idea on set, if you have, let's say, square root of 18, it's the same as writing square root of 9 times 2. Because 9 is a perfect square. So this is the same as writing square root of 3 squared times 2. And it's the same as square root of 3 squared times square root of 2. And that is the same as 3 times square root of 2. Wow. Now, if I have, let's say, square root of 3 divided by 16. This is the same as square root of 3 divided by square root of 16, which is the same as square root of 3 divided by square root of 4 squared, which is the same as square root of 3 on 4. Wow, we are going to use this basic idea. Now, it means that if I have square root of 3 divided by 4, I can write this as square root of 3 divided by square root of 4 squared. And this will give me square root of 3 divided by 4 squared. And I'll go back to square root of 3 on 16 as I have here. So we are going to use this basic idea. Note it very well. Now, for limits involving rational functions, because this is a rational function, we have this divided by that. So now, what are we going to do? What we are going to do here is that we are going to take the highest power of x in the denominator and divide it, and divide 4x by it, 1 by it, and divide each term in the radical by that highest power of x. So here, if we look at the denominator, the highest power is x. So what do? We will take 4x and divide it by the x, plus 1 and divide it by the x. So in this case, you don't have any problem. If we take the radical, that is, if we take the square root of x squared plus 4x, we will divide this one by x. But we want this x to go inside the radical. That is where we use this idea. Very simple as that. So we will take the square root of x squared plus 4x divided by square root of x all squared. Wow, that's the idea that I've explained. So now we can write this as square root of x squared plus 4x all divided by x squared. So simple, very, very simple as that. So let's go to it and simplify it. So now we are going to have this one as the limit as x approaches infinity, square root of x squared plus 4x divided by x squared and the square root all divided by 4x divided by x plus 1 divided by x. I hope I've explained this. Now, this one is going to give us the limit as x approaches infinity, square root of x squared plus 4x all divided by x squared. Then we have 4 plus 1 on x. Simple. So here I'm going to have the limit as x approaches infinity, square root of x squared divided by x squared plus 4x divided by x squared divided by 4 plus 1 on x. Let me put this in brackets. Yes, it's in brackets. Wow. So let us proceed. What are we going to get? We will have the limit as x approaches infinity, square root of 1 plus 4 on x divided by 4 plus 1 on x. Now, as x approaches infinity, what do we take? Let's take the limit of the numerator and the limit of the denominator, because the limit of a quotient is the quotient of the limit. So we take the limit as x approaches infinity, square root of 1 plus 4 on x divided by the limit as x approaches infinity, 4 plus 1 on x. Very simple as that. And the top one will give us the limit as x approaches infinity, 1 plus 4 on x under the square root divided by the limit of 4 as x approaches infinity plus the limit of 1 on x as x approaches infinity. Now, here too, this will go inside. So what are we going to get? We are going to get this one as the limit of 1 as x approaches infinity plus the limit of 4 divided by x. 4 is a constant, so we can factorize the 4 out as x approaches infinity divided by the limit of 4 as x approaches infinity plus the limit of 1 divided by x as x approaches infinity. We have this one and this. The limit of a constant is a constant, so here for the numerator we have 1 plus the limit of 1 divided by x as x increases infinitely. 1 divided by infinity will give us 0. 4 times 0 will be 0. All divided by the limit of a constant is a constant, so we write 4. 1 divided by a very large number will be 0. So we have square root of 1 divided by 4, and that is 1 out of 4. I have explained this into details because that is the first example. As we move on, we will just escape some of the properties and then go on. But if you get this question at session B, you have to go through this procedure to get the full marks. Now, let's move on to your question. Now, in this question, we are having x approaching positive infinity. So it implies that the square root of x squared is equal to the absolute value of x, and that is x. Because the absolute value function simply means what? Either you go to the left or right, because absolute value means the distance between a number and 0. So for that distance, it can be on the right hand side of 0 or on the left hand side of 0. Now let's go to this part. Here we are taking x approaching negative infinity. That is, we are taking values of x less than 0. Negative infinity means values of x less than 0, right? So here we are taking x less than 0 because of what we have here. So the absolute value of x, if x is less than 0, is equal to negative x. If x is less than 0, it's equal to negative what? X. Now, we are saying that the square root of x squared is equal to the absolute value of x. So if you consider values of x less than 0, this will be equal to negative x. Very, very simple as that. So let's take this and that and equate. We have square root of x squared equal to minus x. For x less than 0. So let's make x the subject. You have minus square root of x squared is equal to x. So this is what we are going to use when you get this case. Rosina, yes. I hope your teacher would, using the fact that square root of x squared is equal to the absolute value of x equal to minus x. Yes. I hope this one was attached to the question. Okay, if it is not attached, if it was not attached, that is the explanation. Now, let's come to the question. So here, we will take the limits as x approaches negative infinity. Square root of x squared plus 4x divided by negative square root of x squared. Because here the highest power here is x. So you divide through by x. And here the x will be equal to this if we are going this way. All divided by 4x divided by x plus 1 divided by x. Wow. Very, very simple as that. So that is the difference between this one and that one. For the first one, x is approaching positive infinity. So we don't have problem dividing through by square root of x squared. But for the second one, x is approaching negative infinity. So here x is equal to negative square root of x squared. That is the whole reason. Okay, so here you take the limit of the numerator and the limit of the denominator. So let's do that. But let's simplify it before. We have negative square root of x squared plus 4x divided by x squared, all divided by 4 plus 1 on x. We take the limit as x approaches negative infinity. We can factor the negative sign out to get negative of the limit as x approaches negative infinity. Square root of x squared plus 4x divided by x squared, all divided by the limit as x approaches negative infinity, 4 plus 1 on x. Very simple as that. And we've done this one already. So you go through the whole process as I did for this one. The only difference is this negative that we've had here. Very simple as that. So you take the limit of this, and that will be negative. The limit as x approaches negative infinity, 1 plus 4 on x under the square root. We factorize the negative sign out. All divided by the limit as x approaches negative infinity, 4 plus 1 divided by x. So let's see that. And what are we going to get? This will be the same as, if you take the limit of this, that will be 1 plus 4 divided by negative infinity. That is, we take 4 divided by negative infinity. 4 divided by a very large negative number will be 0. So it will be 0. Then bring the square root sign. There's a negative here. Divided by the limit of a constant is a constant. So if we take the limit of this, it will be 4. Then this will be plus 1 divided by a very large negative number. We've done this in lesson 2, lesson 1. So if we divide 1 by a very large negative number, you get 0. So this will be 0. So we'll be having negative square root of 1 divided by 4. And that will give us negative 1 out of 4. Rosina. That is the answer to your question. Very, very simple as that. It's negative 1 out of 4. So if you get a question of this nature, that is how you approach it. I'm going to solve different questions to improve your understanding. Just keep watching. So for that question, the emphasis was that the square root of x squared is equal to the absolute value of x. And if we take x less than 0, the absolute value of x is equal to negative x. And if x is approaching positive infinity, the square root of x squared is equal to the absolute value of x, that is equal to s. That is for x approaching positive infinity. This one is if we take the limit as x approaches negative infinity. So keep note of that. And this one is if we take the limit as x approaches positive infinity. This is negative infinity, this is positive infinity. Very, very simple as that. Now let's move on. What about this question? Let's look at this after I've solved Rosina's question. Now, Rosina, you've understood yourself. Let's take this question. I want us to look at this. If we take the limit, square root of x to the power 4 plus 3x divided by 1 plus 2x squared plus x. As x approaches negative infinity. Now how do we solve this one? You see that if we look at the denominator, the highest power of x here is x squared. So what do we do? Okay. We have to divide this by x squared, this by x squared, and this one also by x squared. And then divide what is inside here by x squared and divide this one also by x squared. So how do we do this one? Now, we know that if I have a, that is square root of a divided by b, I can write it as square root of a divided by square root of b squared. And that is square root of a divided by b squared. So let's use that approach here. So this will give us the limit as x approaches negative infinity, square root of x to the power 4 plus 3x all divided by square root of the denominator is our b, so we take 1 plus 2x squared plus x all squared. And here, if the square cancel the square root, we come back to this. Wow. A very nice approach, right? Okay. Now, here, this is the same as the limit as x approaches negative infinity. We have square root of x to the power 4 plus 3x divided by, let us expand what we have here. 1 plus 2x squared plus x all squared is the same as 1 plus 2x squared plus x times 1 plus 2x squared plus x. 1 times 1 is 1. 1 times the whole of this will give us the same thing. 2x squared times 1. 2x squared times 2x will give us plus 4x to the power 4. 2x squared times x will give us plus 2x Then we come to x. X times 1, x times 2x squared plus 2x cubed. And x times x will give us plus x squared. So here we have 1, 2x squared plus 2x squared is 4x squared. Plus another x squared will give us plus 5x squared. Wow. We have here to be x plus x will give us plus 2x. We have 2x cubed plus 2x cubed will give us plus 4x cubed. And we have here to be plus 4x to the power 4. In fact, let's go back to check if our multiplication is correct. 1 times the whole of this will give us 2x squared plus x. 2x squared times 1 gives us 2x squared. 2x squared times 2x squared gives us 4x to the power 4. And 2x squared times x will give us 2x cubed. X times 1 is x. X times 2x squared will give us 2x cubed. And x times x will give us 2x squared. So we have 1 here. There's no any other like term. We have 2x squared plus 2x squared, 4x squared plus x squared. That will give us 5x squared. So we are right. We have x plus x, that is 2x. And what again? We have 2x cubed plus 2x cubed. That is 4x cubed. And we have plus 4x to the power 4. So we write here 4x to the power 4 plus 4x cubed plus 5x squared plus 2x plus 1. Wow. Very simple as that. And now, the highest power of x in the denominator is x to the power 4. Very simple as that. So let's do the division and we are done. Let's do the division. So here we will take the limit as x approaches negative infinity. Square root of x to the power 4 divided by x to the power 4 plus 3x divided by x to the power 4 all divided by, if you divide it by x to the power 4 you get 4. If you divide it by x to the power 4 you have 4x. 4 divided by x plus, if you divide it by x to the power 4 you have 5 divided by x squared. If you divide it by x to the power 4 you have 2 divided by x cubed plus 1 divided by x to the power 4. Wow. Very nice approach. Now x to the power 4 divided by x to the power 4 is 1. So we are, let's go fast. X divided by x to the power 4, you have here to be x to the power 3. So let's do it fast. Now, as x approaches negative infinity, let's see. We are going to have square root of 1. Because 3 divided by a very large number will give us 0. 4 divided by a very large negative number will be 0. 5 divided by a very large negative number squared will be 0. 2 divided by a very large negative number cubed will be 0. 1 divided by a very large negative to the power 4 will be 0. So it will be left with 4. And square root of 1 out of 4 is 1 out of 2. Wow, very simple. Now, let's look at it from the polynomial function approach. Now, you see that this one is the same as taking the limit as x approaches negative infinity. Square root of x to the power 4 plus 3x divided by the limit as x approaches negative infinity, 1 plus 2x squared plus x. So now, you see that the top one will be the limit as x approaches negative infinity, that is the numerator, x to the power 4 plus 3x all under the square root, divided by the limit as x approaches negative infinity, 1 plus 2x squared plus x. Now, we've said in lesson 3 that for a polynomial function, you just look at the term that contains the highest power of x and take that highest power of x. So this one is the same as writing this as the limit as x approaches negative infinity, square root of x to the power 4, and forget about the 3x. And this one too is the limit as x approaches negative infinity, we take 2x to the power 2. Wow. So now let's deal with that. So here, what are we going to get? Let's see if we still get 1 divided by 2. So you can solve this using this approach. So this one will give us the limit. I'm sending it back. Square root of x to the power 4 as x approaches negative infinity divided by the limit 2x squared as x approaches negative infinity, the same as the limit of x to the power 4 to the power half as x approaches negative infinity. Oh, there's no need for breaking it this way. So let me write it this way straight so that we don't waste more time. So this is the same as writing the limit as x approaches negative infinity, square root of x to the power 4 divided by 2x squared. And here, what is square root of x to the power 4? X to the power 4 is the same as x squared, and we are taking square roots. So this will cancel this. So this will be the limit as x approaches negative infinity, x squared divided by 2x squared. And that's x squared will cancel x squared and we have 1 divided by 2. So we take the limit as x approaches negative infinity, 1 divided by 2. 1 divided by 2 is a constant, so we have 1 divided by 2 as we have had earlier. So you can use the first approach or the second approach. But for the first one that we have done, you defined the square root of x squared against the absolute value of x, if you have that case. But for any other ones like this, you go through any of these two procedure and you get there. And remember that for what you have done here, the 2 and the 4 are even numbers. So it is very, very easy for us to deal with that if they are both even numbers. But if they are not even numbers, situation will change. And you look at this one here, this even number is less than this even number. And in fact, if you square these two, you are going to get 4. That one also helps us in doing it. But if you get, let's say, here to be 6 and here to be 2, if you square this, you get 4. It will not go and cancel this. That one also be a different a different process. Okay. So let's see. If we assume that here is x to the power 6, let's see that one fast and go. If we take that place to x to the power 6, then what will happen? So what we do is that we will just ignore this term and we ignore this and that. So we take the limit as x approaches negative infinity, square root of x to the power 6 divided by 2x squared. And what will happen? This is the same as x to the power 3 squared and the square root, and this is 2x squared. So let's take the limit of this as x approaches negative infinity of this. So we are going to take the limit as x approaches negative infinity. This will cancel the square root. So we have x cubed divided by 2x squared. Wow. This will be the limit as x approaches negative infinity, x divided by 2. Wow. Now, what will happen to this? As x approaches negative infinity, we are going to have negative infinity divided by 2, which is the same as negative half of infinity. And if you multiply negative half by a very large number, you will still get negative infinity. Very simple as that. So if that one happens to, you go through that procedure. Okay. Or you can go through the expansion as I expanded this, and then you get it, you get there. So I've shown you two approaches to this. Now let's take the next example. Rosina, I hope now you are getting very well with this. Now let's look at this one. We are going to take this. I have this one. Let me take the limit. As x approaches negative infinity, square root of x squared plus x plus 1 minus x versus the limit as x approaches positive infinity, square root of x squared plus x plus 1 minus x. Wow. Now, shakaka. Let us do direct substitution and see. Let us do direct substitution and see what will happen here. Now, upon direct substitution, we are going to have this. The limit of this, if we take the limit as x approaches negative infinity, x squared plus x plus 1, all under the square root, minus the limit of x as x approaches negative infinity. Let's see what we are going to get. We are going to have negative infinity squared minus infinity plus 1, all under the square root. Wow. Minus infinity. So here, what are we getting here? As x approaches infinity, we are going to have square root of infinity minus infinity plus 1. Plus infinity. So what will happen here? Yes, what will happen? Here, minus infinity does not exist because I don't know the infinity. How do I subtract infinity from it? So minus infinity does not exist. But let's look at something here. If we consider this, if we consider this one as the limit as x approaches minus infinity, x squared plus x plus the limit as x approaches minus infinity of 1, all under the square root. Now let's look at this one. Here, as x approaches negative infinity, what will be the behavior of this? We've done it already. Here, this one will not be important. We will just take the limit of x squared as x approaches negative infinity. And this one will give us positive infinity. Wow. And here, we have plus 1 because the limit of a constant is a constant. And then we take the square root of this. Very simple as this. Now, what is infinity plus 1? I don't know infinity. So plus 1 means I'm just adding something to the infinity to go to infinity. So this one will be infinity. So infinity plus 1 is infinity. I don't know the infinity and I'm just increasing it. So I'll still go to infinity. And the square root of infinity will be infinity. Very simple as that. So here I'm going to get this one as infinity. And this one will be minus infinity. and it will be minus infinity plus infinity. And what is infinity plus infinity? Infinity plus infinity is just a simple infinity. I don't know infinity, and I'm just increasing it by infinity. So I'll still go to infinity. But remember that infinity minus infinity, we don't know. Because I don't know the infinity. How do I subtract what I don't know from what I don't know? But here, I don't know infinity, but though I'm increasing it, so I'm still going to infinity. So that is why we have this. So here, this limit will go to infinity, and it is positive infinity. From what we have done here, just check the idea here very well. Check the procedure very well. If we take the limit of all these and we do direct substitution, we can't get it. But if you consider this one as 1, and then you consider this one, because you can group it that way, it is addition. So you can add this, and after that you add this. So you take this one and take this one. That one, it will go. Very simple as that. Now what about the other one? Now, for this one, if we look at this one, we are saying that this one will approach infinity. But for this, it will be minus infinity. And minus infinity minus infinity, we don't know. So that is why rationalization will come in. So we take the limit as x approaches infinity, square root of x squared plus x plus 1 minus x times square root of x squared plus x plus 1 plus x, all divided by square root of x squared plus x plus 1 plus x. Now let's rationalize. This will multiply this. We are having x squared plus x plus 1 minus x. Watch my video on limits involving rational functions and then involving radicals, that is square roots. You will get to understand it. This time this will give you that. You just multiply this by that to get x squared, right? All divided by, all this is over 1. So you are going to get square root of x squared plus x plus 1 plus x. This one will cancel this. Remember to bring the limit as x approaches infinity. And this will give us x plus 1. The limit as x approaches infinity, x plus 1 divided by square root of x squared plus x plus 1 plus x. Wow. So let's see what happens here. Now, we can do something. Let's look at this one. The highest power of x here is this x. Because if we consider what is under the square root, this x squared will be important. So here, we take this x. Very simple as that. So we divide this one by x, this by x. We divide the whole of this by x and this by x. So this will give us the limit as x approaches infinity, x divided by x plus 1 divided by x, all divided by square root of, now since we are going to divide by x, and x is approaching positive infinity, we can take square root of x squared inside this. So we have x squared plus x plus 1, all divided by x squared. We have done this one already. Plus x divided by x. We've done this one already. So this will give us the limit as x approaches infinity, 1 plus 1 divided by x, all divided by square root of x squared will cancel x squared, we have 1 plus x divided by x squared gives us 1 on x squared plus 1 on x rather plus 1 on x squared plus 1. That's what we are going to get. So divide x squared by x squared, 1. X by x squared, 1 on x. 1 divided by x squared, 1 on x squared. Now, as x approaches 0, what are we going to get? Sorry, as x approaches infinity, you take the limit as x approaches infinity of 1, you still get 1, so put 1 there. You take the limit as x approaches infinity of 1 on x, you get 0, so plus 0. That is for the numerator. Then here, this one will go to 0, this one will go to 0, so you're going to have square root of 1 plus 1. That will give us square root of, 1 divided by 2. Because square root of 1 is 1, 1 plus 1 is 2. That is the answer for this. 1 divided by 2. Wow! Very amazing. So you check how I did both and you see that we are on the way going. Now let's take the next example. This video is very lengthy, but it contains a lot. Rosina, I hope this one will reveal more secrets under this lesson for you. Now let's take this one. What about the limits? As x approaches infinity, we are taking the cube root of x to the power 4 plus 3x divided by root 2 times x to the power 4 plus 2x cubed. Wow! How do we solve this? This is very tedious. But we get there. Let's go. This is the same as the limit as x approaches infinity. Take the cube root of x to the power 4 plus 3x. Look at the denominator. The highest power of x is x to the power 4. So divided by x to the power 4, divided by x to the power 4, or divided by square root of 2x to the power 4 divided by x to the power 4 plus 3x cubed, or divided by x to the power 4. And what do we see? We have the limit as x approaches infinity, cube root of 1 plus 3 divided by x cubed, or divided by square root of 2 plus 3 divided by x. Now as x approaches infinity, 3 divided by infinity cube will be 0. So we are going to have the numerator to be 1. Divided by 3 divided by infinity will be 0. So this is root 2. Wow. So this is the same as the cube root of 1 divided by the cube root of root 2. Wow. Lovely mathematics. Cube root of 1 is 1. What is the cube root of root 2? This is the same as 2 to the power 1 out of 2 to the power 1 out of 3. And that will give us 1 on 2 to the power 1 out of 6. So you have 1 divided by the 6th root of 2. To raise the power to the power, you multiply the index. 1 times 1, 1, 2 times 3, 6. So that will be the answer for this. Now let's check the next example. In the next example, we are going to consider this. This is not difficult. The limit as x approaches negative infinity. We are considering the 5th root of x squared minus 3x plus 5, all divided by x minus 1 times x plus 2. So here, in simple terms, just expand the denominator. So you take the limit as x approaches negative infinity, the 5th root of x squared minus 3x plus 5, all divided by x times x plus 2x, negative 1 times x minus x, negative 1 times 2, negative 2. This will be the limit as x approaches negative infinity, right? The 5th root of x squared minus 3x plus 5, all divided by x squared plus x minus 2. And we are good to go. Now the highest power of x in the denominator is x squared. So this will be the limit as x approaches negative infinity. We take the 5th root of x squared divided by x squared minus 3x divided by x squared plus 5 divided by x squared, all divided by x squared divided by x squared plus x divided by x squared minus 2 divided by x squared. Wow. Now this one will be the fifth root of 1 minus 3 on x plus 5 on x squared, all divided by 1 plus 1 on x minus 2 on x squared as the limit as x approaches negative infinity. Now as x approaches negative infinity, 3 divided by a very large negative number will be 0. So this will be 0. This will be 0. This will be 0. This will be 0. So we are going to have the limit as x approaches negative infinity, the fifth root of 1 divided by 1, and that will be the limit as x approaches negative infinity, fifth root of 1, and the fifth root of 1 is 1. So you write 1. The limit of a constant is a constant. So this limit will be 1. Wow. Let's go on. Very, very nice. Or when you reach here, you can just do it very simple without going through this. This is a polynomial function inside the radical. So you can forget about the whole of this. Because x squared is the one that will be considered. And here to consider this x squared. So you just take the limit as x approaches negative infinity, fifth root of x squared divided by x squared. And this will be the limit as x approaches negative infinity, fifth root of 1. And that will be 1, as we have done. Very simple as that. Okay. So this be the last example, what I have here. I think it shouldn't be. Let's look at this one. I have the limit as x approaches infinity 2 times the square root of x to the power 5 plus 8 divided by square root of x to the power 4 plus 7x to the power 5. So here we just consider the highest powers of what? X. So what do we do? In this way, you don't have any x attached to this, so we forget about that. So we take the limit as x approaches infinity to square root of x to the power 5 is x to the power 5 out of 2 divided by here, the highest power is x to the power 5. Yes, so you know x to the power 4, right? So you take 7x to the power 5 under the square root. So this will be the limit as x approaches infinity, 2x to the power 5 on 2 divided by 7x to the power 5 on 2. For square root of this will give us, okay, square root of 7 from this. Note that if you have square root of 7 times x is the same as square root of 7 times square root of x to the power 5. And root of x to the power 5 is the same as x to the power 5 on 2. So in this case, this one will cancel this, and we are going to have the limit as x approaches infinity 2 divided by square root of 7. That is the same as 2 divided by square root of 7. Wow, 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 wow. Very, very simple mathematics. And this one can be written as 2 root 7 on 7 if you rationalize. Now let us proceed. Oh, you are enjoying the lesson, huh? Let us proceed. Now, I think this will be my very last example that I'm going to do. I'm going to take the limit as x approaches infinity, 5x minus 2 divided by square root of 3x squared plus 1. So in this case, you are going to use the same idea. You have the limit as x approaches infinity, 5x divided by square root of 3x squared. Wow. So this will give us the limit as x approaches infinity, 5x divided by root 3, and you have root x squared. Oh, we've done this already. So we take this one as the limit of 5 divided by 3 times x as x approaches infinity. Or this one will cancel this. Oh, okay, we have x here. And it's the same as the limit as x approaches infinity, 5 divided by 3. And that is the same as 5 divided by 3. In fact, this is not the example that I wanted to solve. Yes, this is the right example. I think this one is the right example. So let's solve that one. Well, this one is very simple. This one is very simple. Here, what we did here was that if you want to go to the former approach, you see that here we have the limit as x approaches infinity, 5x minus 2 divided by square root of 3x squared plus 1. So if you consider this one, the highest power is x squared. So how do we remove x squared from the square root and bring it to the top? So x squared is under the square root. So if I want to remove it, I'll get x. That is very simple. So if you divide here by x squared and divide here by x squared, the numerator will be 5x divided by x squared minus 2 divided by x squared. Because we've taken this x squared out from the square root to here. So it will be xx, not x squared. If you want x squared to go away from the square root, so that is what we have. So this will be equal to 5 minus 2 on x divided by 3 plus 1 on x squared. Hope you've seen that. Very simple. Oh, here we are having square roots. Okay. And it is under the square roots. So if we take the limit as x approaches infinity, this one, we get the numerator to be 5. 2 divided by infinity will be 0. 1 divided by infinity squared will be 0. So it will be left with 3. So we can use this approach to arrive at the same answer. Remember, I said that I have 3x squared. If you look at the polynomial, the highest power is x squared. So I have x squared under the square root. So if I want it to go from the square root, I will take square root of x squared, and that will be x. So that is why you divide this by x, divide this by x, but you divide each here by x squared. Very simple as that. Now, I don't think this will be the last example. Let's see. I love teaching, and you to love watching my videos. Now, what about this one? In the same way, let's say that this is approaching negative infinity. If this is approaching negative infinity, what do we do? The first example that we did, we said that square root of x squared is equal to the absolute value of x, which is equal to negative x, if x is less than 0. So here, we want x squared to come out. So here, square root of x squared will be equal to negative x. And here we have negative square root of x squared equal to x. Wow. So what do we do? That's what we are going to do. So in this case, we are going to have this one there. We are going to take this one. Let's do it here. You have the limit of 5x minus 2. We divide this one by x. We divide this one by x. Okay. We divide this one by, yes, x. And divide this one by x. As x approaches negative infinity. All divided by, we take the square root of 3x squared divided by x squared plus 1 divided by x squared. But what do? We attach the negative what? Sign. Because we have the negative here. Very simple as that. Or we can say that yes, we have that one there. So let's put it there. Okay, here we'll use this one. So let us bring the negative here. Right? That is good. Let's bring the negative here because we will divide here by negative x. We divide here by negative x. It's the same as leaving the negative outside and dividing 2 by x. Yes. I hope that is clear. Because we are going to have negative square root of x squared equal to x. And that the square root of x squared is equal to negative x. So here we are taking square root of x squared out. And since we are approaching negative infinity, this is the same as negative x. So we divide this one by negative x and divide this one by negative x. So it's the same as leaving the negative outside and dividing it by x. If you multiply the negative 2, we get the same thing. Right? So let's see what we are going to get. I can factorize the negative out to get negative times the limit as x approaches negative infinity, 5 minus 2 on x, all divided by square root of 3 plus 1 on x squared. And what will happen? Negative. As x approaches negative infinity, 2 divided by a very large negative number will be 0. So the numerator will be 5. 1 divided by a very large negative number will be 0. So the denominator will be square root of 3. And that one will give us negative 5 root 3, all divided by 3. If you rationalize it. Wow. I think we've done a lot of examples, but it has left with just one for us to finish. I hope this one is clear. This one is very, very clear. If it is not clear, let me take it again because it is you that, because of you that are here. We have square root of 3x squared plus 1. I want to take this x squared out. So we take root of x squared equal to x. But here, we are approaching x from the negative side. That's x approaching negative infinity. So we are saying this is equal to the absolute value of x, which is equal to negative x. So here, square root of x squared is equal to negative x. This implies that if I take 5x, I'll divide it by negative x. Minus 2, I'll divide it by negative x. And I said that it's the same thing as leaving the negative here and dividing it through by the x. As we have here. Very simple. But for the denominator, we have 3x squared divided by x squared plus 1 divided by x squared. Very simple as that. That is what I was explaining. Now, let's take this very last example. That is the limit as x approaches infinity, 2x to the power 5 plus 6 divided by square root of 5x cube minus 2x squared plus 8 versus the limit of 2x cube plus 6 divided by square root of 3x to the power 5 minus 4 as x approaches infinity. So let's do this one first. So here, the inner one is a polynomial, so this one is not important because this contains the highest power of x. So we take the limit as x approaches infinity, 2x to the power 5 divided by 5x cubed. This is under the square root. So this will give us the limit as x approaches infinity, 2x to the power 5 divided by root 5 times x to the power 3 out of 2. So we have 2 out of 5 as a constant. So we have 2 out of 5. Sorry, 2 out of square root of 5 as constant. So we have 2 out of root 5. The limit as x approaches infinity, x to the power 5 minus 3 and 2. And if you subtract this, what do we get? We have 2 on root 5. The limit as x approaches infinity, this will be x to the power 7 on 3. And if you have watched lesson 1, this will approach positive infinity. So we are going to get 2 on root 5, infinity to the power 7 on 3. And that will give us infinity. Because infinity to the power 7 on 3 is infinity. 2 root 5 times infinity will still be infinity. Very simple. Now let's look at this one. For this one to have the limit as x approaches infinity, 2x cubed divided by square root of 3x to the power 5. For these terms are not important. So we take the limit as x approaches infinity. I'm tired. 2 divided by square root of 3 times x to the power 3 divided by x to the power 5 out of 2. Wow. Why is it 5 out of 2? Okay, let me make this 1 so that what I'm guessing will come true. Let's take this one and this. Yes, I want us to get a negative number. So you take the limit as x approaches infinity. I've changed the quotient. I want us to get a negative exponent. 2 on root 3 is a constant. This will give me x to the power 1 minus 5 on 2. And we have 2 on root 3. The limit as x approaches infinity, x to the power negative 3 on 2. Wow, that is it. 2 times 1 is 2, minus 5 is minus 3 on 2. So this will give us 2 on, root 3 times the limit as x approaches infinity. This one will be 1 divided by x to the power 3 on 2. And we have 2 on root 3 times 1 divided by infinity exponent 3 on 2. So if you have not watched lesson 1, check that video. So you see that 1 divided by infinity to the power 3 on 2 will be 0. So 2 on square root of 3 times 0 will be 0. So this one will approach 0. And I'm done. Thank you for watching. Please like, subscribe and share. Leave your comment too. Bye bye.